Hello, everyone. So today's lesson is lesson 2.6, which is about writing polynomial functions. Some of these are going to be fairly simple, and some of these are going to get a little complicated. So this first example here, those of you who have this worksheet, I did include a 0 here. You might have a 6 in the front of this first example, but I'm including a 0. So change that if you have a 6 there, or if you don't have a number there, put a 0 there. Okay, so the directions are to write a polynomial function f of x of least degree that has a leading coefficient of 1 and the following roots. So basically, these are the answers to your x-intercepts on your polynomial graph. So we haven't done graphing yet, but when we do, you're going to see that these numbers here are where it's going to cross the x-axis or bounce on the x-axis or touch the x-axis. But getting ahead of myself here, so what we want to do is just write the function f of x. Oh, also, for my students, please put your name on your paper in ink on every page if you haven't already. And today's date is 4/7/2020. All right. So if we have a polynomial that has these solutions, you need to take these solutions or roots and write the factors that go with them. So the factor, when you're writing your linear factor, is always going to be x minus whatever the root is. So that's how you set up your, put a different color here. So you're always taking x minus the root. That's one of the reasons why when you are solving, the solution ends up having the opposite sign of what is inside of the factor. So, for example, well, 0 is a little bit more complicated, but not really. If I have a solution or a root of 0, that means I'm going to have a factor. So also f of x is what we're writing an equation of. So your equation should start with f of x equals. So if I take this idea here and write the factor that has the solution of 0, it would be x minus 0, because 0 is the root. But whenever you subtract 0, that's not really necessary. X minus 0 or anything minus 0 is itself. So x minus 0 is just going to give us a factor of x. We don't even need parentheses. The negative 2, if I take x minus a negative 2, is going to simplify to a factor of x plus 2. So even though the root is negative 2, your factor is x plus 2. And then we have this interesting number here, 4, that has a multiplicity of 2, which means there are 2 factors that have a solution of 4. So both of these factors are going to be x minus 4. You could also write it as x minus 4 squared. So now we have this. So these are all the factors. This is where they came from. This is where we're at right now. Now what we need to do is write our equation in standard form. So we want to have a least degree polynomial that has a coefficient of 1. And I should probably put in the notes here, in standard form. So in this section, in this lesson, you do need to write this in standard form. Later on in Unit 3, we're going to allow you to leave things in factored form. But for right now, you are required to write this in standard form, which basically means we have to multiply it out. So I'm going to start with the x and the x plus 2 by simply distributing the x to each term of my binomial. So I now have x squared plus 2x. And then you've got this x minus 4 squared to deal with. Now there is a rule that I want to make sure you guys pay attention to. Trying to pick a color here. I wish I had more choices. Okay, so this is a very important rule that we're going to use again and again and again. Whenever you have a binomial squared, a plus b squared, it will always equal a squared plus 2ab plus b squared. So whenever you have a binomial that's squared, it will multiply out. When you multiply it out or put it in standard form, it becomes a trinomial. So the shortcut kind of to this, I mean, I'll show you both ways. You can rewrite it as x minus 4 times x minus 4 and then distribute the x and then distribute the negative 4. Or when we start seeing these a plus b squared, when we start seeing these squared binomials over and over and over again, it just makes it easier if you can follow this pattern. So you basically are going to take your first term and square it, plus 2 times the product of your first and second term, plus your second term squared, is basically what you're doing. So this is your first term in the binomial. This is your first term in your binomial, and then your second term in the binomial goes here and there. So if I apply that formula to this x minus 4 squared, I know it's going to become a trinomial. So if I take my first term, which is x, and square it, I get x squared. If I take, so this is just your first term, which is x squared. The middle term comes from taking 2 times your first term, which is x, times your second term, which is negative 4. So if you multiply, so plus, but the sign is going to change there in a second. But the formula is plus the 2 times the first term times the second term. So plus 2 times my first term, which is x, and times my second term, which is negative 4. So if I multiply 2x and negative 4 together, I will get a negative 8x. And then my third term in my trinomial, I take the second term, which is negative 4, and square it. Well, when you square negative 4, you will always get a positive here. So that becomes our new trinomial. Now, don't mix this up with your sum and differences of squares when you're factoring. With the sum and differences of squares that you're factoring, the trinomial is not this here. It's very similar. It's a squared, and it could be plus ab or minus ab, but there's no 2 in the sum and difference of squares formula. This is not factoring. This is multiplying. So we're finding the product of x minus b squared, or a binomial squared. Now, the other alternative, if you don't like to use that product rule, which again, I'm going to encourage you to continue to try to use that product rule because that will be helpful for you. But you could take your x minus, let's see if I have, no room up there. So you could take that x minus 4 times another x minus 4 and multiply it out. So I'm trying to find a little space where I can squeeze that in there. So if you were to take your x minus 4 times an x minus 4 and multiply it out, the x times the x would equal x squared. The x times the negative 4 on the outside would be negative 4x. On the inside, you would get, when you multiplied or distributed the negative 4 to the x, you would get another negative 4x. And then when you distribute the negative 4 to the negative 4 times negative 4 is a positive 16. So again, you can see that if we combined like terms, we would still get this trinomial. So your x squared would be your first term. When you combine the negative 4x's, you get the negative 8x. And then when you take that 6 plus 16, goes there. All right, well, we are not quite done here with our f of x equation. It's not quite in standard form. We have a binomial now times a trinomial. So I am running out of room here. So I am going to see if I can zoom this in a little bit. Oh, there we go. Zoom plus. Okay, so I'm going to take that over. I'm going to take this binomial and multiply it by that trinomial. And I'm going to use this space over here. Come on. Okay, so get my pen going again. I will use green this time. Okay, so yeah, I shouldn't have used all this space over here. I'm going to erase some of this over here. Ooh, can't do that. Hold on here. Okay, there we go. Now I'm erasing. I need more space. All right, so two. All right, it does not want to cooperate. Okay, all right, well, that 2 is just going to have to stay there. All right, so now we're going to go back to green here. So over here we had f of x equaled x squared plus 2x times x squared minus 8x plus 16. So you can distribute each of these terms individually, or you can create a box. Some of you did a really good job of multiplying your binomials and trinomials using like a table. So if we put our binomial on the side in front of each row and our trinomial on the top above each column, and then multiply just like a multiplication table. So take your x squared times your x squared, and we get x to the 4th. Take your x squared times negative 8x, and you get negative 8x to the 3rd. X squared times 16 will be a positive 16x squared. And then take your 2x and multiply it to all 3 of them. 2x times x squared is 2x to the 3rd. 2x times negative 8x is negative 16x squared. And 2x times 16 is a positive 32x. So then what we do is combine our like terms. And if you notice, your like terms are usually in the diagonals. Not always, but a lot of times this works this way. So you've got your leading term here, your x to the 4th, and this will be your last term, the 32x. And let me go back to my green, and I'm ready to write my final answer. F of x equals x to the 4th. Combine your x to the 3rds, and you get negative 6x to the 3rd. Combine, actually, what's going to happen to your x squareds are going to cancel out because we've got a positive 16x squared and a negative 16x squared. So we can cross those out, and then plus 32x. So there we have it. All right. And this is now in standard form, where we started out. Where's my? There we go. So we started out in factored form. So this is factored form. We started out creating our factors, then simplifying a little bit, then multiplying them out, and then multiplied the binomial and trinomial. And again, then we got Why does this thing not want to cooperate? There we go. And we get this final answer. Okay, so hopefully that made sense. And please let me know if you need help. I don't want this clicker. Okay. All right, so now let's go back to our next thing here. I'm going to zoom out a little bit. Where was that zoom? More tools. No. Oh, there we go. Minus. No. Okay. All right. So the next theorem that we are working with is called the Irrational Conjugate theorem, or root theorem. So an irrational number is a lot of times a square root. There are other irrational numbers like pi and e, which you'll learn about in the second half of this class. But a lot of the square roots and cube roots, a lot of the radicals are irrational numbers. So basically what this is saying is that if you have a polynomial that has a root that's irrational, you cannot have the positive, you have to have two roots that have that same irrational number. One is going to be a plus the square root of b, and the other would be the a minus square root of b. And these are called irrational conjugates. So if you have one root so you cannot have one without the other. So if you're told in your directions that you have a root of -7 plus the square root of 6, that means you also have another root, but be careful. Look at the a. The a is your rational number. The rational number does not change sign. It's the irrational number that changes sign. Just like when we are solving with quadratic formula, your negative b plus or minus the square root of b squared minus 4ac. So your a is kind of like where the negative b would be, where this is a number, and the square root is plus or minus the square root of b. So basically, you basically have a plus minus the square root of b. This is your pair of conjugates together. But if they're written separately, or if you're given only one of them, and you're asked what is the irrational conjugate of this here, the -7, which is the rational number, is not going to change. It's the square root that has the opposite sign. So -7 plus square root of 6 and -7 minus square root of 6 are your conjugates. They make up the pair of -7 plus or minus the square root of 6. So this is the pair of conjugates. And again, you cannot have one without the other. I can't get rid of those. Okay. I'm not going to worry about it. All right, so the next one, instead of a binomial, instead of having two terms, it's only one term. So basically that's telling you that the a value would just be 0, and we don't need to have another number in front here. But 2 square root of 15 is positive, which means its irrational conjugate is -2 square root of 15. So the pair of positive and -2 square root of 15, that is a pair of irrational conjugates. All right, so there's also a complex conjugate rule, and a complex number is a number with an I, or imaginary number. So sometimes you'll have irrational numbers and complex numbers in the same answer, but this rule specifically is talking about the complex root. So any root that has an I in it. is called a complex number. Again, you'll see this A here. The A is your rational number. The A does not change. So kind of like this 4 here is your rational number. But the positive and negative BI is what we're looking at. Those make up the two different conjugates. So you have a complex conjugate of negative 5i. So in this case, your A value, your rational number, would just be 0. So it's not necessary to write it. So if you have a root of negative 5i, that means you also have a root of positive 5i. So that is its conjugate. So the pair would be positive and negative 5i. And you've seen solutions like this when we were solving polynomials, where you would have positive and negative 5i. When you took the square root of negative 25, you would get positive and negative 5i. All right, so the 4 plus 7i, if we wanted to answer the question, what is the complex conjugate of 4 plus 7i? It would just be 4 minus 7i. So that's one root. This is another. They are two different roots, but if we wrote them as a pair of complex conjugates, you would have 4 plus or minus 7i. So notice the 4 does not change. It's the plus or minus makes up the two roots in front of that 7i, in front of the complex root. All right, I'm having a hard time talking today. Okay, so the next, so the whole reason why I wanted to introduce that is to build you up to some of these roots or these functions that are a little bit more, a little bit harder. And we're going to be having roots with square root of 5 and positive and negative 2i. So let's change our color here. All right, so the negative 7 is a rational number. Rational numbers do not have conjugates. So when I'm writing this polynomial f of x in factored form, it's going to be x minus the negative 7, which is going to make this positive 7. So the root of negative 7 is going to come from a factor of x plus 7. Now the square root of 5 is irrational, which means it must have a partner or a conjugate. So if this is positive square root of 5, then its conjugate is negative square root of 5. And we can then create or write two more factors, one of them being x minus the positive square root of 5, so x minus square root of 5. And then this next factor is going to be x minus the negative, which then would make this positive square root of 5. So these are our three factors. The negative 7 gives us the factor of x plus 7. The positive square root of 5 comes from a factor of x minus square root of 5. And negative square root of 5, the root of negative square root of 5 comes from the factor of x plus square root of 5. So now we're going to multiply this out. Now, another really important rule, or rule, I guess, that we use a lot is the sum and difference rule. So whenever you have a sum or a difference, so we're just going to call it a plus b times a minus b. Whenever you have a sum or a difference, if you multiply your a times your a, you get a squared. But if you multiply the a times the negative b, that's going to create a negative ab. If you multiply the b, then distribute the b to the a, you get a positive ab. And when you distribute the b to the negative b, you get a negative b squared. So the middle terms essentially cancel out. So whenever you have a sum and a difference, you end up with just a squared minus b squared. So when you notice that you have this pattern of a sum and a difference, where the first term is the same and the second term is the same, but your signs are different, you don't have to get 4 terms and then cross out the middle term, because you already should know that those middle terms are going to cancel out. So instead, just set this up as the first term squared minus the second term squared. And this is always going to be minus, because you're always taking a positive times a negative. You have a positive square root of 5 times a negative square root of 5. So my first term is x. when I square it, I get x squared. My second term is the square root of 5. I've already taken care of the sign here with this negative, because a negative times a positive is a negative. So the square root of 5 times the square root of 5 is the square root of 5 squared. Well, what's nice with this, when you're squaring the square root of 5, that square and square root kind of undo each other, cancel each other out, which then leaves you with x squared minus 5. But now the 5 is a whole number instead of a radical. All right, so now that we've multiplied these two binomials together, we don't forget about the third one of x plus 7. And again, don't forget your f of x equals. We're writing a function, and we're naming it f of x, because that's what the directions tell us to do. And now we were going to multiply these two binomials together. So if I take my x times my x squared, I'm going to get x to the third. If I take the x times the negative 5, I'm going to get negative 5x. But I'm going to leave a little bit of space. I'm going to put it over here, because when I multiplied my 7 times my x squared, I'm going to get a positive 7x squared. And in standard form, the x squared should come before the x. And then take your 7 times your negative 5 and get a positive 35. So now we have our equation in standard form. Oh, I did want to tell you that in your homework assignment, problems 1 and 2 are like example A, or similar to. Problems 3 and 5 are similar to this example F here. And then numbers 4 and 6 are going to be similar to letter G here. And then letter H, I'm going to actually add a problem, number 11. I'm going to add that to the back of your worksheet. And I would like you to do the same. But there wasn't a problem like it, but I want to make sure that you do a problem like this. Okay, so going back to example G. First, we need to set up our factors. So if we have a root of 3, and don't forget your f of x equals, that had to have come from a factor of x minus 3, because it's always x minus the root. Since they tell us there's a root of negative 2i, don't forget there must also be a root of positive 2i. So we actually have 3 roots, not just 2. But rational numbers do not have conjugates. So there's only going to be one factor of x minus 3, unless they had a multiplicity of 2. All right, so the next factor, x minus the negative 2i, actually becomes positive in that factor. And then if I take x minus the positive 2i, that's going to give me the factor of x minus 2i. So once again, we've got that pattern of x plus 2i, x minus 2i. So we have a sum and a difference of the same thing. So we're going to multiply those together first. So when you do that, you take your first term squared, and the first term is your x, minus, and that minus comes from taking the positive times the negative, the second term, which is 2i, and squaring that. So first term squared minus second term squared. So when we simplify x squared, that's the easy one. But if you had a number in front of that x, you'd have to make sure you squared that also. I think we have that coming up in a little bit. Now here, the 2i squared is going to be a little tricky. That 2, the square, gets applied to the coefficient of 2 and to the I. So when you square the 2, you get 4. When you square I, you get I squared. And then we bring down the negative. However, there is a problem. I squared is actually equal to negative 1. So when you square an I, no longer is it an imaginary or complex number. It now becomes a real number. So that -4, when you're multiplying it by I squared, you're really multiplying it by -1. So now what's going to happen to that? Well, the -4 and the -1 multiplied together will equal a +4. All right, so remember way back when we were factoring and we said that x squared, when you cannot factor a sum of squares with real numbers? Well, you can factor it with imaginary numbers. So the linear factors of x squared plus 4 are actually 2x plus, are these here, x plus 2i and x minus 2i. So very similar to your, when you have x squared minus 4, you would get x plus 2, x minus 2. But when it's plus 4, you have to have that I with the 2. Because when you multiply that I times another I, you get I squared, which is -1, which changes the sign to positive. All right, so all of that just to multiply those two binomials. Now bring down the x minus 3. And don't forget your f of x equals. So now we have a binomial times another binomial. No big deal. Take your x times your x. We're ready to set up our final answer. And you get x to the third, x times 4. I'm going to leave some space because I have a -3 times x squared that I'm going to want to put first. The x times the 4 is going to be positive 4x, and your -3 times 4 is a -12. So now we have our polynomial in standard form. All right, so the next one is a fun one. I was going to keep on and use green, but I always keep changing my color. So the next one has not only a complex root, but it also has an irrational root, which actually means that both of them have conjugates. So you have a root of positive 5i, but you also have a root of negative 5i because you cannot have one without the other. If you're given a root of -3 square root of 13, then there must be another root of positive 3 square root of 13. So there are actually 4 roots in this polynomial, or f of x. So now that we've listed all 4 roots, or all 4 solutions, we are now going to write our factors. So again, we're going to have 4 factors, x minus 5i, and x minus a negative, which makes it plus 5i. And then the factors that come from your -3 square root of 13 and positive 3 square root of 13, x minus a negative makes that positive 3 square root of 13, and then x minus the positive, which does not change the sign, 3 square root of 13. So now we have a setup here. We've got 2 sum and differences. So I'm going to start out with this one here, the x minus 5i and the x plus 5i. So when I multiply those together, I take my first term squared minus my second term 5i squared and simplify. So the x squared just becomes x squared. When you square the 5, you get 25. Also bring down this negative. When you square your I, you get I squared, but don't forget, I squared, it becomes -1. So when you multiply the -25 by the -1, you actually get x squared plus 25 when that's all said and done. All right, so that's just these 2 factors being multiplied out. So now we have to multiply these 2 factors out. Color, blue. All right, so again, take the first, we have a sum and a difference, which basically means, again, we have the same first term, the same second term, the sign in between is different. So take your first term squared minus your second term squared, which is the 3 square root of 13. So when I square the x, I get x squared. Bring down my minus. The 3 has to be squared, which will be 9. And then when you square the square root of 13, the square and the square root undo each other. So now you actually have 9 times 13. So you have x squared minus 9 times 13, and 9 times 13 is, just a second, 117. So this all this work gives you this binomial here, and then we had this binomial here. So now our f of x, let me go back to green actually. Cannot get my eraser to work. Okay, so now our f of x is equal to this binomial, x squared plus 25 times this binomial, x squared minus 117. So now we multiply these together, distribute the x squared to this x squared, and we get x to the fourth. Distribute this x squared to that negative 117, you get negative 117 x squared. Then distribute the 25 to the x squared, and you get positive 25x squared. The positive 25 times the negative 117 is a negative 2,925. So combine your like terms and we'll be done. So x to the fourth, combine your middle terms, negative 117 plus 25 will be negative 92x squared, and then bring down the negative 2,925. All right, so now we have it. That is our answer in standard form. And just to review a couple of concepts, the degree of this polynomial is 4, which means there are 4 roots or solutions. And here they are: positive 5i, negative 5i, negative 3 squared root of 13, and positive 3 squared root of 13. Those are the 4 solutions or roots to this polynomial. All right, moving on to our next page now. Now this is going to be the one that's a little bit more difficult, so bear with me. Take a break if you need to and come back to it. But we have two roots. The 2, which is the easy one because it's a rational number, but this 1 minus 3i is going to have a conjugate of 1 plus 3i. But these roots are the ones that are going to get a little tricky to write your factors for. So let me see here. It looks as if, okay, I might have another example on your paper, letter J, but I don't see it on here. So I will try to make room for that letter J. Okay, so keep in mind that when you write your factors, the factor is always equal to x minus the root. So when we have a binomial root, so let's start out f of x equals 2. It comes from a factor of x minus 2. But here's where this gets interesting now. So it's going to be x minus the binomial 1 minus 3i. So x minus this binomial root is what it looks like. And then another factor of x minus this binomial root, which is 1 plus 3i. So now if I simplified these factors here, that negative would have to be distributed to both terms. So now we have a trinomial x minus 1 plus 3i, and another trinomial when I distribute here of x minus 1 minus 3i. Okay, so now here's where it gets, again, interesting, or I'm going to try to help you make this problem a little bit easier. So if you notice that x minus 1 part is the same. So if I regroup this, I call this regrouping, and instead of putting the 1 minus 3i and 1 plus 3i in parentheses, instead if I put x minus 1 in parentheses, and I look at the pattern here, we basically have x minus 1 in front, plus 3i minus 3i. So we have a sum and a difference. So to make this a lot easier to multiply, we're going to use that product rule again that says if you have a plus b times a minus b, it will equal a squared minus b squared, which again is your first term squared minus the second term squared. So if you think of this binomial x minus 1 as a single term, and you write this as x minus 1 squared minus the second term, which is 3i squared. So this is your first term squared minus your second term squared. Your first term being x minus 1 and your second term being 3i. All right, so hopefully that makes sense. So now we're going to continue to simplify this, starting with this x minus 1 squared. Well, here's that other rule that we talked about on the other side, that if you are squaring a binomial, it will multiply into a trinomial. The first term squared becomes your first term. The middle term is plus 2 times your first term times your second term, and then plus your second term squared. So this is the other important product rule or special product rule that you need to know. It will make your life a lot easier. Now you could always rewrite the x minus 1 as squared as x minus 1 times another x minus 1 and then multiply it all out. But again, make it easier by taking this x minus 1 square and make it a trinomial. The first term is x. When you square it, you get x squared. Then it's going to be, you're going to multiply the first and the second term together. So if I'm multiplying, think of x and negative 1 multiplied together. That would be negative 1x. But if I double it, because my rule says multiplying the product of the first and second term and then double it. So if I have x times negative 1, which is negative 2x, and double it, I get negative 2x in the middle. And then when I square the negative 1, I get positive 1. All right, so again, just like if you needed to on a separate sheet of paper, you could rewrite the x minus 1 times another x minus 1 and multiply it out and get the same thing. So x times x is x squared. On the outside, you get negative 1x. On the inside, you get another negative 1x. And then negative 1 times negative 1 is positive 1. When you combine your middle terms, you get negative 2x plus 1. So this is the same thing that we have going on right here. All right. This is driving me nuts, but I can't erase. Okay. It's just not going to erase for me. All right, so moving on, simplifying the next part of this problem, which is your 3i squared. So again, this 3i, go back to writing utensil. So you have to square both the 3 and the I. Bring down your negative. So this negative hasn't changed yet. Square the 3 and you get 9. Square the I and you get I squared. But I squared equals negative 1. So when you multiply negative 1 times negative 9, you now get a positive 9. All right, so bring down this trinomial, x squared minus 2x plus 1. What do you notice? The 9 and the 1 are like terms. So when we put this together, we now get x squared minus 2x plus 10. Whew. All right, so this x squared minus 2x plus 1 is our quadratic polynomial that we get from the factors of 1 minus 3i and 1 plus 3i, or I'm sorry, the roots of 1 minus 3i and 1 plus 3i. And one more interesting thing, if you were to take that x squared minus 2x plus 10, set it equal to 0 and solve, you'd have to use quadratic formula. And if you solved for x with quadratic formula, you would get 1 plus and minus 3i. So these would be your roots that would come from setting this equation equal to 0. All right, but that's not what we're doing today. We are not solving, we are multiplying and writing polynomials. All right, so this x minus 2 has been waiting a long time to get involved. Now it's part of the game. So bring that down. And then we have to multiply this x to all three and the negative 2 to all three terms. We're going to distribute the x and the negative 2 to all three terms. Okay, so let's find a light color here. So x times x squared is x to the third. X times negative 2 is negative 2x squared. X times 10 is a positive 10x. Then distribute the negative 2 to the x squared, and we get another negative 2x squared. Negative 2 times negative 2x. Be careful with your signs. That's going to be a positive 4x. And negative 2 times 10 is going to be a negative 20. Don't forget this. Now combine your like terms. So I'm going to rewrite it over here. Change my color back to purple. So f of x. And our final answer, we have x to the third. Combine the negative 2x squared with the other negative 2x squared, which gives us negative 4x squared. Combine your 10x with your 4x, which gives you positive 14x. And then minus 20 is our constant. All right, so again, using that fundamental theorem of algebra, if you have a polynomial that has a degree of 3, then it should have 3 roots. And this does have 3 roots of 2, 1 minus 3i, and 1 plus 3i. All right, so there you have it. Oh, here's my letter J down here. All right, on your paper, you might have it off to the right. So if you don't have enough room, you can always write it on a separate sheet of paper. All right, so here's my last example. Thank you for staying with me. All right, so you have a root of 0, negative 8, negative 2 plus square root of 11. That is one number. That is one root. Don't separate them. Its conjugate is negative 2 plus the square root of 11. Remember, the rational number does not change. It's just, oops. Oh, darn it. I cannot. Okay, I'm just gonna, it's frustrating. Oh no, that's not what I meant to do. Okay. All right, so I'm just gonna cross that out, put negative 2 minus the square root of 11. I don't know why my erase feature is not available, but this is really frustrating. Okay, so like I was saying, this negative 2i or negative 2 stays the same. It's just the positive square root of 11 and negative square root of 11 that change. Okay, so going back now, we're ready to write our factors of our function f of x. So again, if you want to, you can put x minus 0, but that's just going to simplify to x. The negative 8 is going to come from a factor of x minus a negative, which makes it plus 8. And here's where we have the interesting factors. So it's going to be x minus the binomial negative 2 plus the square root of 11. Close that. And then x minus the binomial negative 2 minus the square root of 11. All right, so again, I can do the easy part first if I'd like, distribute the x. So we have x squared plus 8x now, but that's going to have to wait because we have to take care of this monstrous stuff over here. So again, distribute the negative to the binomial. So we have now x negative times negative is positive 2. Negative times positive is negative square root of 11. In the next binomial, you have your x, negative times negative becomes positive 2, negative times negative becomes positive square root of 11. Okay, so this is now our trinomial, but again, remember, we're going to regroup this. So when I regroup, I want to have a first term minus the square root of 11 and something plus the square root of 11. Well, what is that something? That something is the binomial x plus 2. So that x plus 2 now becomes my first term. So that x plus 2, put in parentheses, so I'm regrouping it, put it in parentheses. So we have x plus 2 minus the square root of 11 and x plus 2 plus the square root of 11. So now we can use our sum and difference rule. Well, let's use the ugly brown color. So take your first term squared minus your second term squared. Well, what's my first term? X plus 2. What's my second term? Square root of 11. We've already taken care of the sign. The negative times the positive is the negative right there. Oh, I really don't like that color. Let me change it back to something else. So now we're going to use our special product rule where we're squaring a binomial. It becomes a trinomial. So the first term squared becomes our first term. Multiply the first term with the second term. That gives you 2x, but then when we double it, we get a positive 4x. And then 2 squared, when you square your second term, you get a positive 4. Okay, if you don't like that, then go off to the side and write x plus 2 times another x plus 2 and multiply it out, and you'll get x squared plus 2x plus another 2x plus 4. Combine your middle terms, you get x squared plus 4x plus 4, which is exactly the same thing that we have going on over here. Okay, now take the square root of 11 and square it. So the square and the square root cancel each other out, which then gives you minus 11. So notice this time the sign did not change. It's still negative. The only reason why, going back to the last problem a little bit, the only reason why this 9 became positive is because we were squaring the I. I squared is negative 1, which is why that 9 became positive. Well, in this particular problem, you're not squaring I, you're just squaring a square root, which means the square root then becomes a whole number. All right, so almost ready to bring in this x squared plus 8x, but not quite. We have like terms going on here. We've got a 4 minus 11. So when I combine those like terms, I now have the trinomial x squared plus 4x minus 7. Now we're ready to bring down the x squared plus 8x. Also, don't forget your f of x equals. And now we have to multiply this binomial times this trinomial. So again, if you wanted to, you could use the table method of multiplying or just distribute. Try to alternate between the two different methods. So the x squared, 8x, is my binomial. And along the top, my trinomial is x squared plus 4x minus 7. So now I'm going to multiply the x squared times x squared, which is x to the 4th. X squared times 4x is a positive 4x to the 3rd. The x squared times negative 7 is negative 7x squared. Now distribute the 8x to the x squared, and you'll get 8x to the 3rd. That is also positive. 8x times 4x will be a positive 32x squared. And then 8x times a negative 7. So we have a positive times a negative. Be careful with your signs. That's going to be negative 56x. So now when we write it all together, our final answer, polynomial f of x equals, your first term is x to the 4th. Your x to the 3rds, when you combine, you get a positive 12x to the 3rd. Combine your 32x squared, or your 32x squared with your negative 7x squared, and you get a positive 25x squared. And then the negative 56 will be our final term. And there you have it. All right, so which problems are like this? So going back to example letter I, example I, is similar to numbers 7 and 9. Example J is similar to problems 8 and 10. Now I want you to do one more thing. So if you have this on your homework, then I know that you watched this video. If you don't have this on your homework, then I'll know you didn't. On your very last page, I want you to add a problem number 11. Oh, and I already have it right here. So please add this problem number 11 to the back side of your paper or after number 10. So we have a root of 7i and negative square root of 10. So that one is like, it's not actually one of the harder ones. It's a little bit easier, but it's similar to or like example H. So please write that down on your homework assignment and practice that problem also. So you have 11 problems now to do. Good luck. I will see you on Zoom if you join me tomorrow. There's our last problem.